here we have a circuit up on the board, and we need to find out what kind of circuit it is. Well, I notice that these two are in series, and I notice that these two are in series. So part of the circuit is a series circuit. I also notice that the equivalent of these two are in parallel with the voltage source and in parallel with R3 and R4. So if I were to redraw it, it would look like this, like a parallel circuit. And in the end, what the voltage source sees is just one resistor. Alright, so let's throw some variables in so we can solve it. We measured the voltage source and we found out it's 30 volts. We measured R1, 10 ohms, R2, 20 ohms, R3, 40 ohms, and R4, 50 ohms. Alright, so now we've got some values. We want to take these two series resistors and combine them into one. So 10 plus 20 is 30. So the equivalent of R1 and 2 is 30 ohms. The equivalent of R3 and R4 is 90 ohms. Now, if we know our voltage source is 30 volts, we know we're going to have 30 volts divided across here, 30 volts divided across here. So this is the same. So 30 volts, we should have 30 volts across R1, 2, and 30 volts across 3, 4. And if that's the case, we would end up having 30 volts across this one resistor. Alright, now we can use Ohm's law to solve our current at this point. 30 volts divided by 30 ohms is 1 amp. And 30 volts divided by 90 ohms should be a third, and we'll check that out. .333 repeating. And before we go back into this one, if we have 1 amp here going this way and 0.333 repeating going that way, we should have 1.333 amps coming into that. So our total current should be 1.333 repeating. And at that point, if we want, we can find our total resistance, 30 divided by 1.333, and we get 22.5 505 ohms. Alright, the thing that's going to be common, this branch has 1 amp, this has 0.333. The amperage is going to be the same in a series circuit, so 0.333 repeating. And the same here. This one should be 1 amp and 1 amp. And again, using Ohm's law, we should be able to solve. So we'll solve for V1. 1 times 10 is 10 volts. 1 times 20, 20 volts. Notice that it adds up. And here, 0.333 divided by 40, times 40, 0.333 times 40 equals 13.32. And 0.333 times 50 equals 16.65. And we've solved the entire circuit. This part will be the same as here. And just to go over the relationship of that series, here, these two are in series. These two are in series. So if we come over here, just to see the relationship, these two switch down to this one. These two switch down to that one. These two come together